Thank you for joining us for the Sky Above, where we'll tell you everything happening in the sky this upcoming month so you can plan ahead and know when to look up. I'm Leah Pizzetti. Here's what's heading your way right now on this October episode. First, it's not just a full moon, it's a supermoon. We'll talk about what makes our final 3 full moons of the calendar year extra special. Then we'll tell you when the next impressive meteor shower will peak this month, and later on, a mission to put a nuclear power plant on the moon, an in-depth conversation on what that will take and why scientists are targeting this goal. I am your host, meteorologist Leah Pizzetti. I'm joined, as always, by NASA's Solar System Ambassador and member of the Seattle Astronomical Society, Keith Crum. Keith, thank you, as always, for being with us this month.
Thank you, Leah. Great to be here.
All right, let's start where we always do.
Yeah, the moon, right?
The moon.
Full moon coming up.
Yeah, let's talk about the timeline first. When will it appear full?
October 6th and 7th.
Okay.
Over those 2 days. It is close to Earth now at perigee, so it's that makes it a supermoon.
Mm-hmm. Okay, well, let's talk about that more in a moment. But October 6th, but then of course we have our new moon, October 20th, 21st.
Yep.
And that is what we like to focus in on here when we talk about astronomy, because that's when our moon is darkest. So we get to see the cool astronomical events. So mark your calendars, 20th and 21st. This is a harvest moon.
A harvest moon this year. So the harvest moon is the moon that's closest to the equinox. So next year, it will be in September.
Interesting.
So it switches around, yeah.
All right, glad we're staying on top of it. Okay, now let's talk about what makes this one special. Super, some might say.
Yeah.
What will a supermoon look like compared to the regular moon?
Well, it's about 7% larger, but about 30% brighter.
Okay.
So, that'll be really significant. Like if you're out on Alki looking back at the city, coming up over the city, it'll look bigger and brighter.
So this is visible to the naked eye.
Yeah. Oh, yeah. Visible. In fact, it's blinding to the.
Okay, maybe not visible. Hang on. It's noticeable. Let's say
noticeable.
You will notice the difference. Okay, good catch. Good catch. Of course, the moon is visible to the naked eye. Okay, but let's talk about why. What makes this a supermoon? What is it that actually makes it appear larger and brighter? Because obviously, the moon is not growing.
Right. So it's closest to Earth at the point called perigee, because the moon goes in a slightly elliptical orbit, and so it'll be 225,000 miles from Earth. And is that what the graph?
226.
226.
It looks like it's around that.
Around that, yeah.
We're talking hundreds of thousands. What's another thousand?
Yeah, that's it, right. And then when it gets to apogee, which is the other end of the cycle, it's about 251,000.
Okay, and the cool thing about this supermoon is that it's not the only.
It's not the only
supermoon. Every supermoon for the rest of the calendar year will be super.
Yep.
And we typically see that. They come in threes.
They come in threes, and as a matter of fact, as I just found out, it's a supermoon in January too, on January 3rd. So we actually have 4 in this cycle.
Wow. Okay, so October 6th, November 5th, December 4th, and January
3rd.
January 3rd. Yeah. Okay, so mark your calendars.
Yeah.
It will be a super moon.
Yeah.
And I always love seeing the full moon pictures. Take photos for us, everybody. Okay, so that's the moon. Let's talk about our meteor shower that is going to fly through the skies this month. What's the timing of this one?
Orionids comes our way and peaks on October 21st.
Okay.
Around midnight, 5 to 20 meteors. I would say that, any time between like the 18th and the 25th of October, because, October it's going to get dicey about, what is going to be a clear night.
Right.
So we'll rely on you to tell us that about when it's going to be a clear night.
Which we'll have a couple days out. We're talking weeks out at this point.
Right. So, so I would say on the 18th, that's a Saturday night.
Okay.
So that'd be a good night to go out about midnight and look for the Orionids. It is the second time we go through the tail of Halley's Comet in this year. We went through it earlier in the year. We talked about that. Also, it's important to know that Halley's Comet doesn't come around every year. You know, it's a long period comet, so it's 76 years. It won't be back to us until 2061.
Okay.
So, but we do go through its tail twice a year, and we get 2 meteor showers out of it.
Oh my goodness. Wow. Okay, so we will take advantage while we can. Okay, meteor shower. I love it. Let's keep talking about Orion. So we talked about the meteor shower.
Yeah.
Does it have to do with the belt at all?
Yeah, well, it's near there. It's
Okay.
in the constellation of Orion, and of course people are familiar with Orion's belt, the 3 bright stars. Right below that is a nebula called the Orion Nebula. Absolutely beautiful. You can see it with your naked eye, better with binoculars, even better with a telescope.
What would this photo have been taken with?
And that
Maybe a telescope?
Looks to me like, that's mine.
Ah, that's yours. How'd you take that?
I took that one with a small telescope called a sea star.
Okay.
And it's a fantastic, we could do a whole show on sea star, but it's a fantastic tool. That looks more like, I would say that's probably either a James Webb telescope, or a
I think it might be.
Hubble image, yeah.
Yeah, incredible. But you can see it with the naked eye.
You just, you know, averted vision, where you look away from it a little bit and catch it out of the corner of your eye. That's called averted vision. That works really well for it.
Okay.
And it's, yeah.
And it just looks like those really kind of creamy colors.
It does through a camera.
Okay.
You're not going to see that with binoculars or a telescope. It will be more like, you'll see that shape, but it'll just be more like grayish, smudgy through binoculars.
Okay, so maybe a good time to get a nice camera. Will the Seattle Astronomical Society be out that night?
Oh, definitely. Yeah.
Definitely,
Yeah,
of course
definitely.
you will. Of course you will.
Yeah.
Okay, so find Orion's belt, look below that for the nebula.
Right below the belt, yep.
Perfect, okay.
Yep.
All right, one of the most incredible things about outer space that I love personally is there's always more to be discovered.
Yeah.
And we just made a cool new discovery with a comet.
We did, yeah.
But what's fun about this comet is who discovered it and how.
Yeah, you know, it just kind of gives me chills, actually, to be honest with you, because a citizen scientist found this. His name is Vladimir Bezugli, and I'm sorry to the Ukrainians if I butchered that, but he's a Ukrainian citizen scientist. He was using NASA data from a NASA orbiting system that looks at the sun. Well, it looks at the sun, but it picks up other things. And this is the 12th one he's found as a citizen scientist. I want to find a comet.
Well, you could, Keith. You could.
I got to try, I think.
Oh, my goodness.
So, yeah.
How often does that happen?
Well, you know, we have a new comet about once a year or so. They come around, but usually they're so dim that nobody pays any attention to them. The special thing about this is it could be a naked eye comet later in October. Again, later in October, the 21st. On the 21st, we have no moon.
Okay.
We have a day moon.
Okay.
So, you know, that would be a good time to go look for the comet. It'd be a very dark night.
What does it look like when you look for it?
It looks like
that.
Yeah. I don't know where. New comet. Yeah. It looks like that. I don't know if those are specifically.
I believe that one is this one. This one's your photo.
Oh, that was my photo.
This is another comet, but that's what a comet looks like.
That would be what it would look like through a small telescope.
Okay.
That would be what it would look like through a big telescope.
Oh, cool. Oh, I love that.
Yeah.
Okay, so you said look for it on that dark night, October.
Yeah, October 21st.
21st, or around there.
Yeah, that's when it's going to be closest to Earth, a mere 23 million miles away.
Just a mere 23 million miles.
Well, that's only a quarter of the way between here and the sun, right?
It's close.
It's close.
It's close, isn't it? Okay, and you actually took a video when you were at JPL of an art piece.
I did an art piece.
What are we seeing
so
here?
Glad we have that. That's SOHO. So that is actually representing the data that's coming up and down between the SOHO mission and JPL.
Wow.
They monitor it. And they built this art piece in their lobby to show represent that data coming up and down. And that's the data that dear Vladimir used to find this comet.
Oh my goodness, that's really cool. Okay, and speaking of discovery, we've hit a fun milestone with exoplanets as well. Let's see, so these are planets outside of our solar system,
right,
of course. NASA has officially counted, do you want to do the grand reveal?
6,000.
6,000 exoplanets
have been found so far.
That's incredible.
Appears nothing very much like Earth yet, but there's a whole thousands more that are in the waiting queue waiting to be confirmed.
Oh my God. I think 8,000 is what I saw on NASA waiting to be confirmed.
Yeah, a good number.
Oh my goodness. And the first one was discovered 30 years ago. So in 30 years, 6,000. That's incredible.
Kind of the 30-year anniversary and the 6,000 just happened to line up.
That's great. I love when that happens. Okay, and let's talk about planets a little more. Within our solar system, though, we have the ability to view some of those planets this month with the naked eye. Yeah. Let's see, what are the planets there? We have Saturn, Jupiter,
Mars
and Venus. Perfect. Yep. Okay, so what will this look like to the naked eye?
Well, Saturn is probably the standout because you can see it all night long right now. And it's really interesting because it's more edge on actually than even that graphic. So when I saw it the other night through my telescope, it looks like an arrow going right through the planet.
Cool.
So it's really different.
Oh, so just a fun thing to look out for in the sky this month. And all month long?
Yeah, all month long. It's pretty much all night long.
Great. Yeah. I love to hear it. Okay, Keith, incredible stuff. A lot to look forward to. We have even more to talk about, though. Still ahead after the break. It's been more than 50 years since we went to the moon, but now we're not only trying to get back, but hey, let's put a nuclear power plant on the moon. I have a special guest joining me to discuss the mission and what this means for space exploration. I am joined now by Washington-based aerospace expert Dr. Roger Myers, who has spent more than 30 years developing, testing, and flying space technologies for NASA, national security, and commercial space missions. You have been busy, and is now the proud owner of R. Myers Consulting, helping guide missions moving forward into space. Welcome, Roger.
It's a pleasure to be here.
I am ecstatic to talk with you today. We have a lot to unpack about the mission to space, but I think it's important to first maybe do a little bit of a history lesson. Of course, the first time humans landed on the moon was July 16th, 1969. That was Apollo 11. Moon exploration continued into the early 70s and then slowed in the late 70s. Why was that?
Budget, really, and the imperative to do it, the reasons to do it. We'd accomplished what we wanted to accomplish, which was to beat the Soviet Union to the. It was a geopolitical program primarily. Science, yes, but a lot of it was driven by geopolitics.
Interesting.
The United States and the Soviet Union each wanting to show the worth of their political systems.
And that's something we're going to unpack a little bit more of what that's going on again today.
Exactly.
We'll talk about that more in just a little bit. But something you just said to me, which I think is so interesting, is the difference between what we did back then and what we're trying to do now is huge.
It's a completely different way of thinking about what we're trying to accomplish. We're trying to go and have a sustained presence on the moon and actually go from not just do science on the moon, but also exploit the resources of the moon. So live off the land more on the moon.
And we were only there for 2 days.
We were there for 2 days before, and we had a rover, and we lived in this little tiny hut. The ascent vehicle on the lunar excursion module. Was a very, very small vehicle. The astronauts would sleep in hammocks for 2 days. That was it. And now we're trying to stay on a sustained basis.
Inhabit.
And exactly. Really be there for months and years at a time.
Wow.
We're trying to build to that capability to do that.
And I'm sure that's going to take a lot of work.
Yeah, exactly.
Who are some of the key players in this race? Because I know there's a lot of people doing it at once. And what does the actual timeline look like?
Well, so right now, the Artemis program, which is the NASA's Moon to Mars program, is using two different types of rockets. One is the Space Launch System, which you see now launching. And that's built by a consortium of companies. Boeing is a major player in building the SLS. But the lander, well, I should backtrack. The SLS only takes the Orion capsule, which is at the top of that and has the astronauts in it, to lunar orbit. It cannot land.
Okay.
When we went before, the Saturn V lifted a very small lander, and so it was one launch to get to the moon. One Saturn V could take astronauts to lunar orbit, land them on the moon, and bring them home. Because we're trying to do a lot more now with much bigger systems, and we're trying to take more people and more equipment, we can't do it with those with one launch.
Yep.
So the SLS launch vehicle that you just saw taking off will take the astronauts to lunar orbit, and then a separate lander will rendezvous with them, will meet them in lunar orbit. They will move from Orion to the lander, and then they will land on the surface of the moon, do their surface mission, come back to Orion, and then Orion will bring them back to Earth.
Wow.
So NASA right now is preparing for the Artemis II mission, which is going to take 4 astronauts to lunar orbit. They will not land. The timeline for actually landing right now, the official timeline is in 2 years, 2027.
Is that overly ambitious?
Yes. There have been recent congressional hearings, and a lot has come out about the status of the landers. SLS is ready. SLS and Orion, they're fine. They will take astronauts to lunar orbit later in February, I think, is that mission, exactly. February of this coming year, American astronauts will be in lunar orbit again.
Wow.
But they won't land because the landers aren't ready. And the United States is using 2 landers, or pursuing 2 landers. One is a Starship base built by SpaceX, okay? And the other is Blue Moon, built by Blue Origin.
Okay.
Both of them are behind schedule, and both of them have a lot of work to do. They're very complex missions to get them to Earth orbit, refuel them in Earth orbit, which has never been done before, get to lunar orbit, rendezvous with Orion, have the crew transfer to Orion, to the lander from Orion, and then land on the moon and come back to Orion. So it's a very complex set of missions. And the reason they have to do it that way is because they're trying to do so much more than we did with Apollo, right? We're trying to have a sustained presence.
So if you could best guess with what we have right now, when will we be established on the moon?
I would say probably a couple years after 2029 probably we'll have our first landing again, 2028, 2029, so a year or 2 later than what NASA was hoping for.
Okay.
And that's really because of the lander development timeframes. I mean, I'm speculating, but I think that's a lot more likely than 2027.
But that's just landing. We're not even establishing yet.
Correct, exactly. To establish, we're going to have to land a lot of cargo. We're going to have to land habitats. We're going to have to land a lot of equipment.
Yep.
We're going to have to land a power system.
And that's what I want to talk about, the power. That seems to be one of the biggest issues and solutions being discussed, is actually putting a nuclear power plant on the moon. How in the world, or out of the world, are we going to do this?
So it turns out that the key to doing this is, one, it's a very small nuclear power plant. It's not a big power plant like you see on, that powers our grids. So these are very small. They're like the reactor itself is like the size of your washing machine. And then the overall system, it's got a big radiator. It's got a lot of equipment that goes to generate the power, transmit the power to the habitat or to whatever equipment it's trying to power. But the important thing is that we're not talking about a big reactor. We're talking about small reactors. And there's a lot of work right now dedicated to making sure they're safe, affordable, and small enough to fit on a rocket and land on the surface of the moon. And I think that we can do that by 2030.
Wow.
With a focused effort, if we think it's important to do as a nation to establish a sustained presence on the moon, And that's a question for policymakers and for the government to answer. But if we think it is important, with a focused effort, we could do it by 2030.
That is incredible.
Mm-hmm. Yeah.
I want to talk about something very complex.
Mm-hmm.
It feels simple at face value, but it is very complex. Who governs space? Why is there this big push to get there right now? And what does that do with whose land it is?
Right. It's a great question, and to be honest, there's still a lot of uncertainty in the answers. There are a lot of legal questions. The Outer Space Treaty, which the United States signed, and is signed by most countries in the world, says that nobody can own property in space. So all celestial bodies are common property. But many countries have now recognized that you can own resources extracted from celestial bodies. So you can go to the moon, and while you can't own the moon, you can't own property on the moon, if you extract oxygen or water or helium-3 or whatever resource, you can own that. So one of the big questions that we have today is, how are those resources distributed on the surface of the moon?
Yep.
And if somebody goes and establishes de facto control, they may not own it, but they still control it. And so if resources are concentrated in ways that allow a sovereign nation to control them, they control those resources. And,
Wow.
and other nations won't have necessarily access to them. A nation might grant them access, but once you control that space, you control it. You can establish a safety zone around it, or you can essentially dictate how people can access that region of those resources. And so a lot of this is driven by uncertainty in where the resources are on the moon. Mm-hmm. There's a lot of interest today in the south pole of the moon, because they're permanently shadowed regions of the moon where water ice is believed, with very high confidence, we believe that there's a lot of water ice in the south pole of the moon, in the craters, the permanently darkened craters of the moon. So establishing control over that would give us access to water. And water, you can make oxygen, you can make hydrogen, you can drink the water, you can use it for agriculture, water is really foundational.
For life.
Exactly, and for establishing a sustained presence on the surface of the moon. Wow. And then there are other resources also. I mean, there's a company, Interloon, is going to get helium-3 from the surface of the moon, and it's a local Puget Sound company.
That's incredible. Roger,
sorry,
we are
lots
out of time.
to talk about.
I think we could sit and talk for hours, but unfortunately, the clock is ticking.
All good.
Thank you so much for your
pleasure.
expertise. This is going to be fascinating to watch through the next few years and decades. I
it will be
appreciate your
exciting.
insight.
Thanks.
Well, speaking of heading to space, a Washington woman is on that mission. NASA just unveiled the next class of who could be part of these missions. That story's next. As the United States plans for the next trip to space, 10 people were just named to NASA's next class of astronauts, and one of them is from Washington. Lauren Edgar is from Sammamish. She's one of those 10 candidates out of more than 8,000 applicants. She's a geologist and has already studied human and robotic exploration of the solar system. NASA officials say they hope the new group may be eligible for flight later on in this Artemis program to the moon, maybe to Mars. And Roger, quickly, we have very limited time here, but I want to ask you, when we talk about this mission to space, where do we rank in comparison to other countries?
Right now, China is considered by many to be ahead of us in the return to the moon. Obviously, we were there. We had many missions to the moon already, but we haven't been in 50 years. And China has a roadmap that gets them a sustained presence on the surface of the moon by 2035.
And what does that mean in the grand scheme of things?
That means that they could establish control over critical resources on the surface of the moon before we do.
Okay. All right. Well, we will see how that pans out. Roger, thank you for that.
A pleasure.
So insightful.
A pleasure.
Really appreciate it. Well, that does it for us here on this October edition of The Sky Above, where we talk about all things astronomy heading our way the upcoming month and years, so you know when to look up. I'm your host, Leah Pizzetti. Thanks for being with us. We will see you next month.